yeah, so that was sort of the overall idea. Almost on time. That's 40, 44.
Can I ask a stupid question?
Sure.
Are you recording this so you're going to put up on the site someplace?
If the audio is good enough, yes. I don't have a mic. Usually you're supposed to wear a mic here and then sync the video with the video feed, but I don't have a mic, so if the sound wall is not too bad, I'll put it up on YouTube, yes.
Well, that's good because there's 3 sessions at the same time that I'm very
That's the
interested.
problem.
Yes.
Feel free to jump. I do, like yesterday I jumped sessions. I usually had like 3 sessions to go on average for every time slot. The last time I actually, the very last time slot I managed 5 sessions. So you kind of go in and see which one. And then you come back to the most interesting.
Raspberry Pi one, which is all the way up the other side.
You get a lot of, 10,000 steps a day is your minimum, right? So anyway, thanks guys for your interest. I think this is gonna be very different from what you expect from Silicon Valley Code Camp, usually originally, but there is a lot of similarities so what's unusual about this is we're trying to apply the software development principles that MVC, the extendability, flexibility, all the stuff that we come to love and take for granted from software development, and see how it can fit into the architecture of dwelling spaces and live workspaces. And so let's sort of see what is possible and how it can be done. And if we are able to do that, what sort of optimization, what sort of potential we can have to reinvent our lives and live work processes that these new approaches will provide. So, excited? All right, so so the idea is to create adaptable multi-use spaces for live, work, and play. The same way we have smartphones that can do literally virtually unlimited number of functionality based on software. So you don't change your device because you need a GPS, or we used to have that, right? We had a dedicated GPS, camera, phone, a bunch of other MP3 player, remember those days? Now it's all on your phone. So, however, we still build dedicated office space, dedicated, living room, kitchen, and most of those places are underutilized. You spend, less than 50% in an office, and then the rest of the day that office is empty. What a waste, right? What if you could do something? What if you could create multi-use spaces that would adjust to your needs as those needs change in the course of your life, and in the course of your day, and as you go through your life. So you suddenly don't need to build all those things. What's interesting is right now the way the system works, it's like probably the least efficient way you can think of, because we build office space, and then we build housing, residential space, and they are usually 10-20 miles apart. So you have to travel back. So you need to buy a car, something that takes you back and forth, and then you're stuck in traffic for the rest of all those few hours that you left out of your life. You're stuck in traffic. You're like, that doesn't seem like a robust architecture for me if it were the computer frameworks or something. My background, by the way, why I'm sort of doing this, early in the day when I founded Web Service Center Corporation's affordable custom software development agency, we developed a bunch of web apps, and we soon realized that it's a lot easier to develop web apps if you have a very powerful, very strong foundation. Because most of the stuff is the same, right? The user management is the same across all apps. The rights management, all that stuff is, so if you have the foundation that provides you enough service, enough resources, all the unique stuff is maybe 20% of. The rest is very, very generic. So we developed that portal framework. Now we use saves us, I don't know, it's 10 times faster. It extends our framework. So why not do the same thing with house? So so overall, this is to improve workflow process. So you don't have to stay in traffic if your house can be turned into an office at a switch of a button, or a couple of simple actions. So the reason to do that is we maximize human potential in general. If you have tools, the more powerful tools you have, the more of your potential can unfold. And if you can think of your house or the environment you stay as a tool, just the same way that your phone is a tool, then you have a completely new, totally different horizons, on a much larger scale, orders of magnitude larger scale. So that's the idea, environments that will inspire, nurture, motivate, and sort of give you performance optimization, better use of resources and new opportunities. So we will talk about what are some of the principles, how it can be done, and actually going down. And I'll show you a couple of pictures that showed that we actually went. I visited my folks in Europe this past summer and had some time, so we put together a bit of a model of that concept, and show you that it actually works. So that's interesting. So the talk will be about an hour. Let's try to make it more of sort of active, proactive talk. So please feel free to ask me any questions if you don't understand something. But I don't want to talk all the time. I want to make this. You might as well just watch this on YouTube if you're not going to be active participants, right? So let's get the most of it. So Q&A. So 30 minutes talk. But feel free, then 15 minutes Q&A, and then if we'll have some time, we can do some brainstorming with our goal-setting tool, and you guys can give your feedback how we can how you can make this reality. How can you build? The goal is right now is to build a model of this house, flexible house, by 2017. So maybe you can give us some ideas how to do that. So create an experimental building environment. So short questions, or please feel free to interrupt me. Keep longer sessions for the Q&A in the end. So what was my inspiration for the sci-fi? Or anything? So Starting Atlantis has this really interesting architecture there, and a lot of modular stuff. It's a sci-fi show spun off from SG-1. Very, very interesting stuff. So this is how it looks. Different. This is your holographic screen, 360-degree view. This is actually real. Some guy in the UK turned his apartment into Star Trek. But imagine if you could have an environment that could sort of allow you to do this without spending a lot of money. So a bunch of screens on the wall or some type of projection. So there's some innovative designs there as well. So some of that was, so the room here at the bottom is an example of multi-purpose. The room, it's a screen. There's actually a shower coming down, so it could be also kind of a shower. And this going down, so you can use it for many different. This is what I talked about before. My portal. So we developed this portal framework, and I'm trying to see if the same principles can be applied to architecture of little workspaces. So what are we talking about is multi-use, modular, extendable, and mobile in correlation to little workspace, right? Should be high-tech, eco-friendly, affordable, and unique, and allow you to improve workflow process. So let's look at some of the examples. We actually talked about this already. Better use of resources. So before we jump into that, I'd like to show you a little video. what is possible, at least in what way. Let's see if we can get sound. Yeah, so you have a cube as a sort of a basic building block. Then you can create pretty much any type of cubic structure. And you have modular furniture. And this is just an example of how flex, some of the things that are possible with this type of approach. So, yeah, when was the last time you did that? Right? And then when a kid comes, when you have a kid, then you have to you build them or you buy them their own cube, and that will be sort of near their own house, right? And they can keep on adding stuff. So it's really one furniture. And of course, the opposite is also true. If you separate, you can very easily divide houses back. Yeah, so that's sort of the idea, and then there's a bunch of other stuff. So starting with this, let's do this. However, the cubes, okay, so. Okay, so, yeah, let's look at the history of architecture, right? So this is Giza. That's how they used to build 5,000 years ago. And this is what we built. That's how we build now. See it? Notice any similarities? Right? So it's kind of weird, right? Nothing has changed much in terms of approach in 5,000 years. So we still use these huge, heavy construction, mostly the same material, stone. It's static, so once you develop it, once you create a blueprint, you don't really change anything. And imagine if you would write software that couldn't be changed, right? You write it and there's a bunch of bugs, and sorry, you've got to, break it down and build it new, right? So nobody writes software, nobody builds computers that cannot be upgraded anymore. So yeah, so this was sort of the concept. So what is better? We just saw this Contour's modular living. A container city system, this is an example. If we have time, we'll look at this later. It's another video that shows one architecture company developed a very flexible container-based housing, multiple level in the UK, in London, east of London, and they were able to really lower the cost of, I think it's like something to the order of $200 per 300 square feet space they rented out. So it's like 1/3 or 1/4 of what's usually what these houses they usually rent out for in London. Okay, so what are some of the principles that can apply to architecture? So MVC, separating functionality from presentation, that can be done with screens or whatever other technology. technology comes along. Extendability. We can add new room spaces. We can adjust existing spaces in real time, hopefully. Multifunctionality, so you can use multi-purpose device. We don't buy single function device anymore, right? Who has bought a Lexus watch or some other watch that can only show you time? I bought this device. This phone can do like 10 things to measure measure temperature, barometric pressure, etc. So our phones are a perfect example. The kids nowadays they don't buy watch, hand watch, because you have everything on your phone. So multifunction, small light. So the same way you sort of write light frameworks and light architecture in software development, jQuery stuff, we can also use light materials, composite materials in architecture to sort of provide this very similar parallel, and also flexibility. If we have the same, software, you have to create frameworks that are flexible to support pretty much any, or as many configurations as possible. So the idea here is that, again, if we come up with an idea for a framework that will support as many configuration options as possible for architecture of little workspaces. It's like a big Lego system, if you will. Then we will have the same flexibility. Some of the principles, we'll have modular design, be standard space, so everything is going to be standardized. And then we'll have layered architecture. So you can think of layers as being drivers, physical layer drivers, applications, OS. Maybe we can do something similar for the architecture of live workspace. Integration and interoperability with other systems and security. So that was sort of the basic principle set. And we know about services and APIs that your software system should provide, right? Why not approach the same? Why not have the same approach to your house, right? So your house, what kind of services do you expect from the house? Probably climate control, right? Multimedia, lighting, sound, etc. Nutrition, not yet, but hopefully coming soon. You heard of this startup out of San Francisco called Soylent. They're actually making personalized meal replacement. So it could potentially give you, instead of you cooking all this stuff, you can. Anyways, that's just one example. Personal hygiene, exercise, sleeping, etc. So those could also all be services that are built into the framework, right? And you just use that. So kind of very similar, probably a little outrageous if you think about it from center. I don't know, you come from architecture. Is that too crazy?
Well, no, I wouldn't say I come from architecture, but there are certain, from what I see, there are certain limitations or limiting factors. For example, you couldn't have a small structure in an area that's like hurricane prone because your cubicles just go flying off, right?
So it all depends.
So what I could see, and I think to some of you, we've already tried to tackle these things. Like, for example, the bed that disappears into the wall.
Yes.
Right.
There's a lot of optimizations.
Yeah, I could see how you could take a space and reconvert it with, the bed disappearing into the floor, or it becomes a gym or something like that. You know what I mean?
Right. But I don't think as great as those improvements are, they don't really follow any particular framework, right? So people are just trying to play.
Sure.
There is no philosophy or framework behind it. Actually, if we have time in the end, I can show you this video from Hong Kong. One guy that converted his apartment. He has a very small apartment, and he watched that, right? 2021 transformer apartment. Yeah, very cool. So he can basically reconfigure his one room to serve like 24 different functions. It's very interesting. So, and one of the services I think also is surveillance, security and defense. So that's what we try to come up that your little workspace should offer. as well as cleaning, utilities, storage, health, and garbage recycling. So let me know if I missed something. What's that?
Is this saying my life's come to this?
Yeah, well, that's...
That's bullet points is your whole life, right?
So, interestingly enough, a lot of design, software design principles like object-oriented stuff and patterns they originally come from architecture. There's this guy, Christopher Alexander, he wrote a bunch of books on these patterns, right? Reusing patterns in architecture. So that's what, so we kind of came in the full circle there. Yeah, so you can read that on Wikipedia. So some of the examples of what's been done. This is a Dutch company, Temple Housing. They are using recycled shipping containers to build pretty neat houses. Usually it's temporary houses for students, for staff, for professors in Netherlands. I think they have the world biggest sort of campus with about 1,000 students living in these things. And this is how they look inside. So not too shabby, I'd say, huh? So, yeah. Adam Kaufman is another guy who works with, he's an architect out of New York. He works with shipping containers. And this is some of the idea. This is almost like a stover rack, right? You put your own stuff. That's pretty interesting. So this is from one architecture exhibition in Barcelona, I think it's Spain. So that's a Domino 120 or Domino 21 system. Mobile dwelling unit is another interesting concept out of a 40-foot shipping container. The idea there is that your house should follow you wherever you go, so you just slide this all in and can ship it anywhere. Slide it out and you go. I think they played around with this in the late 90s. Really didn't take off. It's too expensive. Okay, so what are some of the, how can we get this done? What are some of the ideas to really see this, how it can be implemented practically, right? So we're thinking about having some sort of modular frame, either what you've seen with the pump house or shipping containers, and then have multifunctional panels or plates that you stuck in the wall, or they can become walls, and they can provide all these services. And the panels would also incorporate furniture. However, so this is what we come up with. So shipping containers, as great as they are, they take a lot of space. You're shipping, if you're shipping shipping container, regardless of how much space how much stuff you put inside, you're still mainly shipping air, right, by volume, most stuff. So it makes sense to disassemble it to its components. So a house like this on the left here can actually be probably disassembled and put on one truck. I think one load, truck load. Because what it is, if you look at it, most of this stuff is empty inside. The volume is there. So the idea is we started this agile development process. What could be? How can we get to that point? So the first point was shipping container. This so the version 0. So this version was the idea is to have 3 types of elements, and out of these 3 types of elements, you can create pretty much any cubic structure, including this house or any other. So the idea is you have a connector pipe, which is 8 feet, 4 by 4, square pipe, steel, aluminum, whatever you like. And they have these 6 socket adapter elements that you basically slide in. And then you have the panel, and then you put the panel could be doors, walls, ceilings, whatever. So you slide, so you have a box, right? So this gives you a box. The big problem, of course, is this adapter. It's not very good. So we can't, there's a lot of problems there, complicated, doesn't load. So we thought, well, how can we further simplify this? So this is FutureLiving Model System 2. And I think I got something. Okay. so this should be first. So FutureLiving modular system V2, we say from this complicated, we can further split this complicated adapter into just two very simple components. Just a steel plate like this and angular connector or brace. You call it brace? Yes.
Can I ask you a question?
Sure.
So, I like the ideas here, just because it's kind of like stirring up stuff.
Yeah.
But what I'm wondering here is what we're optimizing. If we're just still completely brainstorming, or if this idea was formed out of some goal. This particular one here. So that I can try to think, is this making any sense? I mean, sure, it can be done, but I'm wondering whether the reason why we move to different houses is because it's already been optimized for total energy. You know, it's cheaper to not to move the house. So I'm wondering what we're optimizing here, or whether we're just brainstorming.
Well, I'm giving you an introduction into a sort of foundation for a future brainstorming that we'll hopefully have some time for later. And the idea is we are trying to create a new framework for architecture. And the reason we need a new framework is because the old one is not as efficient. You know, we talked about all these problems that we build dedicated spaces that are empty half of the time, and it's a lot of resources, and a lot of wasted resources. So I think it's still easier if the house is available for this. It's not going to be how it's going to be a live workspace. It's going to be like a place you stay in.
So you're optimizing for a single location, minimizing the number of square feet of space and using it efficiently.
Yes, part of it, but also you can move it easily, much easier than a normal house.
So that
I
probably
think
makes sense in Hong Kong where land prices are really, really, really high, and not so much in places where land prices are not so much.
yeah, but if you have flexibility, maybe I want to move to Hawaii for the next couple of years, and I'd like to take all my stuff with me.
Would it be more efficient just to purchase a place in Hawaii as opposed to moving your house to Hawaii?
I think the contents are generally the things that you value,
Right,
and the house kind of not with that.
Right. And oftentimes, especially in the Bay Area, it's not so much whether or not you can afford to build more house on a plot, but whether or not your plot can support more house. So having the flexibility to increase the size of your house is not that practical. At least here in the Bay Area, because we're landlocked. See what I'm saying? So typically, you get married, you have a family, you move to another house, probably a house that's probably been there for a while as well. You know, most houses in the Bay Area, especially San Francisco, they're centuries old. You know, they've been there a long time, and people just move out when they're ready to move out, and people move in when they're ready to move in. You know, it might be a different problem, I guess.
I think it's a different approach. It's a way to sort of rethink the whole process on a very high level.
Right.
Yeah, the problem with moving in the old houses, the swooping out. First of all, you always have to sacrifice something. You know, maybe you cannot find the place exactly the same what you like, the place you like for the price you like. With here, you don't like maybe the neighbors would really bad or something. This you can take it and move it within a day or something to a new place and don't have to worry about neighbors. You know, try to think of it as a software problem, right? If you don't like your software, you go somewhere else, or you move, or you don't like. Let's say you have your own web application. If you don't like the hosting provider, very easy to move it to another. We have Cloud Foundry and stuff like that. So this is more of you have your own web app, and so the house.
Correct. But a lot of the, like you're saying, like a lot of the external things, like the walls and stuff like that, those are fairly standardized already. You know, you bring your toaster from one house to another, you know the electricity is going to work there anyway. You don't have to bring the house with you, to make sure your toaster works.
You don't have to, yes, and the fact that you can move it may not be important for you. Maybe for you the important factor is that it's cheaper, that it's more flexible. You can have a new room or second floor without much of a work because it's already.
Right, but also those standards have already been built into existing architecture. I guess is a lot of the.
Well,
right?
have you tried adding a new, second level to
Yeah. Oh, yeah. I mean, I guess a house is built, a lot of houses that are built to be single-story aren't designed to have a second story on them. For cost savings measures, I suppose.
So I have one thought here. So there is an optimization concern with ability to easily move between locations. And there's another optimization to be able to use the minimum or use the space all the time for everything,
Right.
which would be kind of more along the lines of what you were presenting in ideas.
Right.
So I think mixing the two things might not provide any optimization at all, not to mention the aesthetics.
I agree with you. It's
So what I
like,
suggest,
yeah, we can say basically it's like, given a small space, how much can you do with it is one problem, right? Internally, like, what can you do with this space to, modify things around in order to make it, more usable for multiple purposes, right? That's one individual problem, right?
well, I don't think one belittles the other, or you can have two at the same time, right? The flexibility of the space does not impede its ability to be moved. So it's
Correct. Yeah.
Sometimes.
Yeah.
Sometimes, yeah.
It depends on
Right.
And I almost, at the risk of taking over your talk.
I think we have some
almost
time.
think that there is a sense of feng shui. So there's a sense of some things should not be on the top of the hill. It doesn't feel right, even if it's possible. So I wonder, that's what's going on in my head. I'm going, what are we optimizing, and is it appropriate, and why? Kind of
It's
thing.
sort of a new frame, yeah. I mean, if you come up with, I think the way, at least what I learned from software development, you don't have to, you try to get as much flexibility as you can possibly, so you don't optimize for the problems that you know exist right now. You try to figure out, you try to provide as much flexibility as possible in expecting that you will have problems in the future you don't even think of right now, right?
So you know what? This is interesting because I heard you talk and ask questions yesterday, and in this field, you're going exactly the opposite way of most software developers. Most software developers are very focused on what should we do today, and that long-term plan, not so much. And this, perhaps that's the difference here. Maybe that's what you're focused on, is creating vast flexibility and framework.
Even in software, I would never hire any developer who would think that way.
Well,
Are you kidding me? So
there's 2 points of view here. You would never hire a developer who thinks all day long and never touches the keyboard either.
yes, but I would rather hire somebody who can predict and model in his brain that this path he's taking is not going to lead anywhere, versus him spending 2 weeks trying to code something that he should have thought through in 2 hours. And this is absolutely ridiculous. You have to get, there is no way a good developer would, they absolutely have to think long term. Because what happens in real life, and I don't know if that's, that's been our experience with all of our clients, almost exclusively all of our clients. They come back, you show them something, you show them exactly what they want today. They come back to you with a list of things they would also want to have on this function. Oh, we didn't know it was possible, right? Oh, now that we see this functionality, we also want to have this and this and this and this. And you come back to them and you say, well, you should have told us that we will need to do, this tangent as well. And they answer, well, so it behooves you to really that's kind of been our experience from day one, 2003. Make it as flexible as possible because you don't know what. And you can, of course, and if you try to predict this, they will pay. You don't have to spend as much time. They will pay. You can charge them for doing, but at least your architecture, your framework will support it. So right now we don't know what's going to happen. We do everything, or yeah. So
If you take the analogy further, I guess like a lot of the way we live now is because of legacy, because of the fact that we have housing structures that have been there for a while, and we use it the way they are because it's cheaper to do it that way, right? So what he's doing is he's thinking, okay, well, forget the whole legacy system. we're doing it from the ground up, what would be the best way of doing it? Sure, it's not practical right now, but, if we had the ability to do it, over again, how would you do it? Yes, right? Is that kind of what you're trying to think of?
Yeah, I mean, maximize, get as much flexibility as possible. And you will find the uses that, like moving these houses together and then separating them later. That's, you cannot even think of. There could be other, more practical uses, I guess, once you really play around with it. Just like the software, I think, once they start using these new features, they come up with new, I think the pace of life and the speed that develop, the future approaches us so fast that we don't know, Kurzweil talks about the singularity going in 2045, or we will not be able to predict what's going to happen after that. Right now, the speed of accelerating in
What year?
2045.
Oh, I think we're much closer than that.
Maybe. Well, he's talking about the advent of real human level AI, practical human level AI that basically be able to solve any problems. So you'll not be able to. Right now, the acceleration, the speed of what's it called? New ideas.
Rate of change.
Yeah, speed of change. It accelerates enormously. So, yeah. So I think it's futile to try to predict what will happen.
So let me try one more. So on this, okay, I'm the customer.
Okay.
I want it. Now, are we going to go with your model, or are we going to go with what I want, or are we going to partner? And that's my point of view on what are we doing here. Are we,
So this is more like a Linux kernel,
okay.
right? And so we're looking for developers, and we're going to do some brainstorming on how to proceed from there. So I think this could well become sort of a
So you're in
foundation.
kernel development?
Yep.
Okay.
I think this is really maybe, I guess kernel development.
Okay.
It could. Anyway, so this
Have you researched your competitors yet?
somewhat.
I'm just kind of curious,
Yeah, I wasn't able to find anything similar, quite like that. Most of the modular spaces, they sort of have. There is one that's very similar, but a lot more complicated. Similar in terms of you can put it together quickly and take it apart, but not as flexible and more complicated. So basically, you understand how, right? So out of this bracket and plate, you can basically make pretty much any connection. And out of this, you end up with a cube. So the cool thing about this is that you can extend. Let's say you want to add a new room here, right? Let's say you want to extend space to, in the x-axis this way, right? Anyway, this way towards yourself. So all you have to do is unscrew these bolts here and put a pipe and add these brackets, and suddenly you have another beginning of a new room. So you can very easily add space in any direction and just put these panels in, and you have a cube. Okay, so this is this is sort of a real life example of what we try to do. So as you see here on the left is an example of this triangular bracket. It's actually a very simple component. You can stamp it out of a steel plate. It's one piece component. Just bend it with press and drill a couple of holes, actually two holes per side, so 4 holes. And then you can use that to make these junctions. And these things here, they provide sort of stop. It's very interesting actually because if you analyze the forces, the vectors of forces going down, so for example, the force will go down right here, and this will try to bend. It will not hang on these bolts, but it will actually lay on. It will try to bend this edge there, right? So you have a lot of support there. So that's what we've been playing around with, and ultimately we'd like to get to this way to, so we can basically create, hopefully, these very, very flexible cubes that you can use to build this hot house type of design, and you can extend. Right, so in this video, cube is the basis. It's the atom that you can break it down. In our design, we go even further, saying cube itself can be taken apart and made. You can split it into these 8 pipes, the connectors, and the panels. So out of that, you're not shipping air. So you can very easily put it on the truck, 8 by 4, and put it anywhere you like. Okay, so any questions so far?
Yeah.
Yes.
Did you consider the module duplicating the frame members for each cube so that you have 2 side by side instead of merging them at the corner?
How do you mean exactly?
Well, like imagine you built 2 complete cubes and then joined them together rather than.
No. Okay, no. Sorry, I didn't. So what I meant is you can extend. You don't have to have 2 walls.
I'm
Yes.
asking whether you considered that as
Oh, absolutely.
a way to do modules because it has some advantages.
Yeah, that's the first thing I proposed, I guess. So I never said we should make 2 separate cubes and then join them together. Well, I guess that's what you saw in the video, right?
What are the advantages of having 2 cubes in the future?
Yeah, there's no. So yeah, so we're saying just extend this cube, and add just whatever needs to be.
No,
added.
I see that you're not joining 2 cubes together. You're extending one.
Right.
To make a second one.
Right.
I'm suggesting that you might consider the other way.
Oh, the other way around. I see. That might be useful in some cases, but I think it will be a waste of material at the edges here. Why would I need 2 pipes in both cases?
Well, for example, it means you could join together 2 existing cubes rather than having to take them apart. That's one. And then you would have thinner beams because you're going to have 2 side by side.
And minimizing labor too.
It seems like a waste of construction, though. It seems like if you can extend that without having to figure that I'm going to just replicate, it seems like there's a smarter way to use less material and less labor to extend it. Right? Putting 2 next to each other seems overkill.
Yeah,
Well,
yeah, that's what I'm
he
saying.
has a point though, because if you're depending on this for the structure, I mean, if you did want to separate it, right, you're essentially kind of taking structure apart in order to separate them, right? Whereas if you have 2 side by side, you take them apart and know that the integrity of the cube is not going to fail.
But taking 2 apart, is it structural? You're redesigning at that point, and it's probably smarter to go ahead and redesign it as an extension.
Yes.
I understand why he did what he did. That's what I'm saying.
Another question for you,
Yes.
your example, your inspiration was Stargate, SG-1, was it? Atlantis.
Portal framework,
So,
our software.
So on this,
SG-1 is just
just in terms of pure urban environments, I mean, would this be able to scale to that? How many floors can you have before the bottom cube cannot support the top cube?
Well, it all depends on what type of material, what type of how big the pipes are. So
Right.
it's more of if you use fiberglass.
If you want to have repetition, right, you're either going to be over-engineering for a small structure, or you have to have several different types of cubes for different layers, I guess. It's not like
Yes,
the same thing,
I
but
think
how's it do?
I think if you have a practical approach, you probably have a basic steel pipe, which is the cheapest material, the 4 by 4 inches, and that will probably support 2, maximum 3 stories. But again, it depends. I think 2 would be the minimum. But if you have a carbon nanotube based material, you can have 10 and 100 stories. Shouldn't be a problem. So again, we're talking about the.
Well, it's not just the weight of the material; it's also the weight of the people living too.
Yeah, I mean, carbon nanotubes will give you enough. How to support them, yeah. If they're thinking about building a space elevator out of those, I think you got enough. Yeah, it's just the cost issue. So what I'm going to show you is actually, let's see, how much time is it?
I don't know if this is going to change your tact, but there's no one that's going to move you out of the room.
Well, I don't want to keep you busy too. Sure. Yeah, it's.
We're not really a captive audience, so.
Okay, so I'll just keep on talking. All right, so what I want to do, guys, now is, we build a website, FutureLiving.info. Please feel free to register there. And if you do, yeah, just click and join the community. So we have a bunch of people over there. You can take a survey. But we have this for Life Focus that is a tool we use to do some goal setting and figure out what the next steps are in different areas. So we're looking at exploring different venues for testing this, set up foundation, partnerships, looking at different partnerships. What I'd like to ask you guys is maybe do some brainstorming about how to move what should be the next step to make this happen, or at least try. Yes.
So I think, personally, you need to pick an optimization.
Okay.
And if I had to pick one right now, I would say minimize energy
Okay.
over some period that's longer than the current path of the Earth being obsolete soon because there's no air left in it, and whatever your greatest worry is. So something about energy.
So energy space, I guess.
Well, energy of construction, energy of movement, energy of the total energy life cycle for a person box or whatever it is.
Right.
So that you're actually optimizing something that you can put on the UN website of how to build a better world.
That's a good idea. They'll give us a lot of publicity, I guess. All right. So we have energy construction, optimizing for energy. Where do we go from there? So we can go one level deeper, or maybe a few other suggestions on the same level, or on this level. So you're basically building a tree of goals, and then we can use that to put down, so we get an overview of different action items, and maybe delegate these goals to different people and see what the progress is. So this is like hands-on project management. But we're doing brainstorming. So you're saying optimize for energy. So in order to optimize for energy, so
I think
what's
you can
next?
build a community if you pick a goal that people are interested in.
Okay.
And then do the experiments that are necessary to show that this is even interesting
Okay.
to anyone.
So we have this work group. So the idea we're trying to approach this is to create these work groups for. So there's a strategy, work group infrastructure. We actually have this on web groups.
So what's the question you're asking?
Okay, so the question is, if we are in this branch, right, select optimization, energy,
So I don't understand the branch yet. What,
So-
so
so
I
this is-
understand my input, but I don't understand this diagram yet.
So this is a basic hierarchy of goals. So if you want to reach this goal, select optimization, you have to reach this. So this is yearly, quarterly, so we're going long-term to middle-term, short-term goals. So we're sort of we're brainstorming the goal tree structure for achieving whatever the goal
So I
is.
would probably get off the computer and go to the board and do some brainstorming on the board, because I don't understand the tree yet, personally. But I don't know what your goal is.
So my goal would be,
Well, others can say something. I don't know.
Are these like physical milestones that you're trying to reach, or are you looking for a starting point? Like, where is?
yeah, so I guess it's not very clear yet. We should have picked another goal. Okay, so let's say the goal is to build, test space by 2017, right?
Does anybody get what's going on here? Okay, so my suggestion from an energy point of view, we're kind of at the end of the day here, is that if you're asking for input on something, I would not use that computer screen. It's going to kill our energy,
Okay,
personally.
sorry, I just want to show you.
That's my opinion. I like some of the other diagrams. I can imagine pictures or something else as a starting point.
Okay. Yeah, I think I had a goal here somewhere. Yeah, create experimental buildings environments by 2017. So that's really that could be a goal. So
Is that's your end goal, I guess?
yeah, I guess we can use that as an end goal.
Okay, so you're picking that date for
5 years or whatever, 4 years.
Can you go back to that? Can you copy that into the next page so we have something to look at?
I can create the. How about this? Future living. Sorry. Space. So this would be a goal, and we have this tree structure, right? So 2017. So the idea is to be able to implement these ideas in real life, test case.
Okay, but why? I mean, that's the key to all endeavors. Why?
Okay.
Why do you want to do this?
Okay.
Me personally.
So I'd like to change the way architecture is approached.
And why are you here in this room at a software-focused world?
Because a lot of, okay, so you're going next
I'm
level.
looking for your real why. Are you trying to make money here, or are you trying to improve the world? What's your why?
I'm building Linux as a foundation. If you compare this to a software, if this were a kernel, you could ask Linus Torvalds the same thing. Why is he doing this whole Linux stuff? Is he trying to make money?
Well, but I'm not asking him. I can guess why he would say, but I don't know.
So
I'm asking you.
I guess it's the same answer, right?
Well,
I'd like
what is
to
it?
change. I'd like to enable a degree of flexibility and openness in live workspaces, architecture in general, that we have never experienced before, that the human race has never experienced before, to fully unfold our, to unfold our potential more. Because right now I think we're stifled by a lot of
And what's your pain point? What's causing you to think that something's painful to you that says that this is something you should work on? You don't like.
I don't like the place I live right now because it cannot be easily changed, adapted to my needs as they change in the course of my life.
You don't like your kitchen as a kitchen.
Yeah, I don't like
I want it to be sometimes a kitchen.
Yeah,
I think it's the goal of most designers, especially industrial designers, is to improve on something that's already there. And that's an understandable goal. My suggestion to you is you don't necessarily, especially in the computer world we live in nowadays, you don't have to necessarily build a physical prototype to begin with. You're probably better off. We have a lot of tools, like texture cost of building a physical prototype. I think it might be a little too early for that for you. You probably have a lot more ideas than what you presented to us. If you show that to us, that'd be great. Do you have like mock-ups and things like that?
Yes.
Kind of things like that?
Yeah, I agree. When you started getting to the actual nuts and bolts of how to do this, I thought that would way premature. I was thinking boltless buildings that interlock naturally, as in the pyramids.
Things that just
Yeah.
slide together.
Or the Incas, who we still don't know how they did it, or whatever it is.
And there's actually, I'm not sure, I was at the Maker Faire maybe it was last year, and there is a sort of an open source physical design movement of sorts.
Yes, open source hardware.
Yeah, it's pretty interesting.
A lot of similar principles. So interlocking, I don't think it's going to work. I played around with those ideas. They will never give you the flexibility you expect from a rigid structure. You need a rigid structure. The interlocking things, I don't think.
Well, don't tell the Incas that.
Because we're very limited, they only knew stone, right? That's all they knew. There was no technology there.
No, but my metaphor is here, we have many centuries of proof that something worked. And it worked just fine because we're still doing it. So why do we really
So why
do
change
something
it?
else? Yeah.
Wow.
So I think history proves that something was already successful. Now we need a reason to change it.
That's kind of a key tip about anything.
Yeah,
it's
really-
it's like automobile, you have the horse and carriage before the.
Well, I'm not against it, but I'm looking
Like,
for the reason.
That can lie we did this.
Well, I
way to
think
change.
so I'm really sorry I came in late because this is really where I want to be. We waste so much energy building houses, it's absolutely insane.
Yeah.
That's the reason. What the solution is, I think this is really close to it, right? We stamp out things that are very easily snapped together is the solution. I think you should work with the D School at Stanford because they look at sustainable living, and the way we build houses right now is absolutely insane.
Well, I was waiting for him to say sustainable living, but he hasn't said that yet. So I'm wondering if that's what this is really about.
Sustainability is one part of this. If you get the whole picture.
And modularity is another piece. Yes, absolutely. So the modularity, the sustainability, the fact that we are gouged by home manufacturers and we're given houses that we really don't want, that don't really fit the purposes that we're trying to maintain. All those reasons. It's kind of insane the way we're doing things right now.
Exactly.
This makes sense, right? This is a nice modular approach that's inexpensive, allows you a lot of flexibility, doesn't use a lot of resources. There's no way that this is not going to happen. The only question is, how long are we going to toil with what we have now before we get to this? Because I'm looking at your site, and this is. So I was at America's Cup, and Puma did their store by bringing in trailer carts, and anyone who did not do that was absolutely doing it wrong because they spent so much time on concrete to build something that was a temporary structure.
Right.
I mean, people can argue that, there's not just one right way of doing things, but there is the best way of doing it, and
Optimization is always local. So best, in your sense, I wonder what best means to you.
when you're building a temporary structure and you don't have an easy way to transport it, you're getting into insanity, right? You're getting into why would anyone not do it in shipping carts? It's there for 3 months tops. And these shipping carts can be rearranged any way you get there. So when you get on site and realize, what I did does not work, very easy to change it. Anyone who did not do that is shooting themselves in the foot.
So I agree, and you've defined the problem as temporary structures. If I define the problem to be a house that lasts 1,000 years,
Well, we can talk about that too.
then that's something else.
No. We can talk about that too, because land shifts.
Yeah.
There are situations in which the house you built cannot sit on the structure you built it on. I have known lots of houses that had to be moved so that the foundation could be repoured because the land is not solid, right? So anything that we try to build that is gonna outlast God is insane, right? Everything.
So here,
This is fast. Maybe it's not a mansion, but it's fast to put up, it's fast to take down, it's fast to rearrange. Ideal.
but it isn't, because here we've already, it appears, and I could be wrong, we're deciding on metal, which
Absolutely.
rusts, and therefore it has some lifetime and fatigues in a particular way, and has earthquakes damage in a particular way, and has energy efficiency, inefficiency.
Let me correct.
And all
Yeah.
kinds of things.
Let's,
So-
you're going really quick and you're making a lot of assumptions I don't think are true. If that was a wooden structure, it'd be much worse off. If it was a concrete structure, it would be as simple to rearrange. I think steel is a very good choice.
And I said specifically that we are not locking into any particular material, right? It could be steel, it could be
Carbon fiber.
it could be aluminum right now if you have enough money. It could be carbon fiber if carbon fiber is really cheap in the future, right? So you're only talking about the framework at the moment. So how you build, what kind of materials you use is totally different.
So my greatest instinct is, I don't know if I want to live in a box of any size at any time. I mean, I do, I actually do, but I don't know if I really want to.
This is a box, right? Everything
So the box is not your personality, but it is bare enough that it's something that we can work with to make your personality, right? So it is simple enough where it can match most people, and it's configurable enough where it can match most people. So you want to start with something like, I am positive that the base of the car that you drive now is not what you wanted, but then when they put the seats in it, and they put the molding around it, and put the color in it, and they put the accessories you want in it, and gave it some personalization with the software that it runs, you're like, wow, this car feels like home. So,
But isn't that the expensive part? Isn't the part?
not if it's done right. Not if it's done right, because the color you're using is probably very close to a color a lot of other people are using with maybe minor tints. So what Tesla did is they said, we're going to build a platform, and this platform is going to allow us to build an SUV, it's going to allow us to build a roadster, a family car, a sedan. Now they're building cars that are about the same cost as Ford, and their next rev will be half the price of Ford, right? But the base unit will not be anybody, right? Because it's not an SUV, it's not a pickup, it's not a roadster, it's not anything. But it's all of those also. So if you can get to the bare core that everyone can personalize, that is the right structure to start with.
As long as you subscribe that a car, as it's currently envisioned, is even the right thing. Because if you look at the Japanese model of this little vehicle, it's certainly not a car, that only has two wheels and stands up because of computer controls. It's far, far from a car, and it may not even have onboard power.
So let me talk about it. But the base of your house we want to extract out all of you and put in just the base that everybody can use. And that's the base we want to talk about right now. And then yours won't look like a box anymore after we're done. Because your windows out of that box will fold up. And you will be having an outdoor space. My box will be very different because I'll have translucent in the front. And our boxes will be exactly the same, but look nothing alike.
So you have strong ideas on a bunch of things, and so what I want to hear from you is, what are you optimizing?
Mm-hmm. So what I'm optimizing, so what I'm optimizing is the insanity of how a house is being built today with so much wood and so much energy, so much cost.
So you're minimizing energy, or you're minimizing material?
Why do I have to choose one? Let me say I'm doing it all. I am minimizing materials, I am minimizing cost, I'm minimizing paperwork, I am minimizing the number of people that are necessary to build it, and I am customizing how you have a visceral reaction to something that's built just for you, because the frame is so simplistic, it allows lots of variations.
I think it's overall is optimizing workflow, right? The
Yes.
whole, you
Exactly.
streamline it, or you basically take it, you forget about the way things were done before, and you try to reach the same goal with, 10 times, orders of magnitude less effort, energy, whatever.
And more customizable, because like what you have here, the Starbucks store, which is the same containers, the house that you have, which are the same containers, and the Puma shop that you have, which are the same containers, have a visceral different feel to them. And when you approach them, you're like, oh, this is Starbucks, I feel at home. Oh, this is Puma, I get it. Oh, this is a house with folding up windows and a pool. Wow, that's really inviting. And yet, they're exactly the same fundamental beginning blocks.
But more importantly, you can turn a Puma shop into your house if you choose to. Yeah.
Exactly.
So you're not wasting anything.
Exactly.
So do you envision then that I move out of my house, Puma moves in the next day and reconfigures the same thing? Or are we talking about still moving this around?
You can do whatever you like. If you want to have a
Let me-
structure.
So I'm going to let you answer, but I want you to talk, but I have to say this. If I could do that, wow.
I have all-
Man, think about how much me and you have just saved the world. If I can move into your house and make it into a Puma shop with no minimum... Give me a hug, brother. That's fantastic.
See, that's what I'm trying to decide. Whether
That would be fantastic.
Because one of the goals he presented was moving this around, and I'm like, does moving things around really help? And the idea of reconfiguring what's there, maybe that minimizes something.
But imagine if we were able to pull that off. How wonderful that I can walk into your house and in maybe 2 days make it into a Puma store, and then come back 2 days later and make it into your house. We all win. Everybody wins. Construction wins. People win. The environment wins. The people are doing it, right? The people who are doing it, right? Because they don't have to waste a ton of energy and money out of their back pocket.
Or they're spending your money to do work. But yeah,
It's going to be much less because you have standard components.
Right.
If you have standard components, you can take those components and reusability. Exactly all of the software ideas, right? Reusability, extensibility, all that stuff kind of comes into play when you have standard components to work with. It's really what we're talking about, right? So,
When I write an iPhone app for you, you will be able to customize it when you look at it.